Assignments yet from last class. I need that now, please. Last chance for full points. Okay, I guess we are not doing minute of silence today. So let me give you a second to make sure you all have that turned down. Okay, last call, any others? You have your notes to look at. It's like the opposite of geometric.
Geometric.
You want P to be greater than 1 if you want to convert.
Right, geometric and P. Thank you.
Sorry, somebody's holding us back. Okay, so today we're going to do similar to what we did last class. I'm going to go through the notes of the next step for you, something called alternating series test. I'm also going to ask you to update your blank piece of paper that you got out last class, and we wrote down the first 5 of our tests. So I am going to ask you to at least update that with the 2 tests we talked about last class, the comparison test and the limit comparison test. So again, that way you have one place where you can kind of see the highlights, the most important stuff. And if you want to add today's to that too, that would be great. I'm feeling a little bit sick here, so please bear with me. Okay, but an alternating series, this is one that I think is a little bit on the easier side, but an alternating series means it alternates between positive and negative or negative and positive. So the second term always has a different sign than the first term. The third term always has a different sign than the second term. But something in there is making it alternate between positive and negative. A very common way to do that, and the most common way, is if you see this. This is what should stand out to you as making it an alternating series. Because if n is 1, you get a negative 1, but then if n is 2, you get a positive 1. And then if n is 3, it goes back to negative. If n is 4, it goes back to being positive. So oftentimes this is the part of the series that makes it switch back and forth between those. Now, only if it's an alternating series like this, we can test for convergence if 2 things happen. First off, the limit as n goes to infinity of a sub n has to be 0. That sounds a lot like what other test? Right, so it's making sure that the n, okay, good. It's making sure that the nth term test is not messed up. And then this one, if we take the absolute value of a term, let's call that term a sub n plus 1, it has to be less than or equal to the absolute value of the term before it. So term n plus 1 is one more term than term n. So that kind of means that it's decreasing, but also if they're negative, it's more like each term gets closer to 0 is a better way to think of that. So ways to try to figure this up. Sometimes you could take the first derivative to see if it's negative. That would tell you if it's decreasing or not. A lot of times you can just look at the number and see that it's decreasing. And then this one, you could manipulate this. So the manipulation, we could like subtract this over And so if the nth term minus the nth plus 1 term is greater than or equal to 0, that's just a different way to say that. And probably the one I prefer, a second way to rewrite it, is if we divide those, we divide a term by his previous term, if it's less than or equal to 1. So this is the one I prefer, but go ahead and write down both. Okay, so that's it. That's all we have to test. We have to make sure that the limit as n goes to infinity is 0, step 1. If that's not true, it diverges. Step 2, we will, well, I tend to do this, take a term, divide it by his previous term. If that is always going to be less than or equal to 1 for all terms, then that's enough to call the second term. And if both of those things are true, we can say it converges. If either of these things are not true, it diverges. But this is only true for alternating series. You can't apply this to other tests. So question 1 here, if I threw this out, if I cross this out, what do we call this series? That's the harmonic series, and the harmonic series always diverges, okay? But we can't just say, hey, that's the harmonic series, it always diverges. We need to treat this as an alternating series now. This is going to switch it up. So let's, now when we talk about the limit of a sub n, I'm sorry I didn't point this out, but when we're talking about a sub n, we're not talking about the -1 to the n power. We're talking about the rest of the stuff. Okay, so in here, this is a sub n. So what is the first thing that has to be true for this to converge? Okay, and just of the a sub n part, it's supposed to equal what?
0.
And does this one?
Yes.
Okay, so if it didn't, you could say it diverges and you can move on. If it does, you've got one more thing that you need to happen. You need to make sure that this is getting closer to 0 over time. So I think this one's kind of obvious, but if you're not sure, you can just plug these in. You plug in 1, you get 1. I'm just worried about a sub n. This is just telling me it's alternating. I plug in 2, I get a half. Plug in 3, I get a third. Plug in 4, I get a fourth. Do you see how this is
Why
any?
are we worried about a sub n at the beginning?
Well, this is telling me that it's an alternating series, and as soon as I realize it's an alternating series, I just care about these first two things. Does the limit of a sub n part equal 0, and is a sub n approaching 0 over time? So if I took any of these terms, like a fourth, and tried to divide it by its previous term, like a third, this has to be true for all of them. But dividing by a third is the same as multiplying by 3, and that is less than or equal to 1. This divided by this would be less than or equal to 1. This divided by this would be less than or equal to 1. So if you take a term and divide it by his previous term, again, I just think this is the easiest way to think of that. If you take any term and divide it by its previous term, if it's always less than or equal to 0, then the second condition is met, and we can say that this converges. Now again, this is totally independent of everything else we've done. This only works because these are alternating series. If you try to apply just these two rules on some other test, you might mislead yourself. Now, if you want to talk about the whole series, that should be kind of interesting to you, because 1 over n diverges. All of a sudden, putting this out front makes it converge. So think about if we really plug these in. If I plug in 1 into this guy would be negative. If I plug in 2 into this guy would be positive. This guy would be negative. This guy would be positive. Do you see how if you started at -1, and then you add a half, and then you subtract a third, and then you add a fourth. Do you see how those things are getting, like, it's squeezing into some finite number? That's what's making it converge. So, okay, so step 1. Well, first off, why is this an alternating series?
The -1 to the n.
Okay. And it doesn't matter if it's to the n or the n+1. That might change whether the first term is positive or negative, but this is what makes it an alternating series. Two things have to happen for an alternating series to converge. The limit as n approaches infinity of a sub n is supposed to be 0. And when I say a sub n, I'm not talking about the alternating part, I'm just talking about the rest of it. So if I plug infinity into this, does that go to 0?
Yes.
Good. The degree of the denominator is bigger than the degree of the numerator, so you can continue to use horizontal asymptote rules. Okay, number 2. Would the n+1 term divided by the nth term always be less than or equal to 1? Okay, so that's a lot harder to figure up, right? So here's what we're going to have to do when we need to work this up. So I'm going to take the n+1 term, which really just means everywhere there's an n, I'm going to put an n+1. So n+1 plus 5 over n+1 plus 2 and n+1 plus 3. So all of that represents a sub n+1. I want to divide that by a sub n, which I'm going to save a step here, and instead multiply by his reciprocal. Divide by a sub n, which is the same as multiplying by his reciprocal. Okay, and then if we try to cancel some of this stuff out, very little of this is going to cancel. We've got an n+3 cancels out an n+3, so might as well simplify it some. We could FOIL this numerator together. And we could FOIL the denominator together. And then I'm going to have to show you, oops, a little trick. Okay, so my question to you a minute ago that you didn't have an answer to is if you pick a term like a sub n+1 and you divide it by his previous term, is it always less than or equal to 1? So I found the n+1 term, I divided it by the a sub n term, I have simplified some and made it rewrite it some. But if you still can't see this, or if you still had to prove it, here's where you can get a little creative. We could leave the numerator alone, and then we could do something with the denominator. We've got an n squared, but break this 9n into an 8n and a 1n, and then break this 20 into a what plus what?
12 and
Very good, a 12 and an 8. How did he know that that should be a 12 and an 8?
12 on the top.
Good, so notice this guy and this guy, I just basically rewrote the denominator so that you could see these are 1, right? So if this divided by this is going to simplify to 1, and you still got some stuff in the denominator, that assures us that that is less than or equal to 1. So both tests were true, so he converges. Sorry, give me a second. I need to update it. Okay, So again, over here, I didn't really have to do too much to figure out that a term divided by its previous term was less than or equal to 1. Over here, I had no idea, so I found a sub n plus 1 divided by a sub n, tried to reduce, tried to match it up, and then once I matched these up to see that these were equal, but there was still stuff in the denominator, I'm sure that that's always less than 1, or equal to 1. Okay, number 3, notice this is an alternating series because of this guy. So all the rest of this is a sub n, and step 1 to be convergent is the limit as n goes to infinity of this has to be 0. Okay, are we good with that? Okay, Calvin, tell us why you're saying no.
Because that approach is 1.
Right. Degrees are equal, so leading coefficient over leading coefficient. So if that's not true, then what's that mean?
It's not converged.
Which means it diverges. Both things have to be true for it to converge. If either one messes up, you can say diverge. Okay, and then 2 more examples here. All right, this does not look like an alternating series. What's missing to make it an alternating series?
1 to the n.
Well, negative 1 to the n. You need the negative. Okay, but this is almost like question 1. Again, sometimes I still think that you guys don't lean on this enough. Sometimes if you're not kind of sure what's going on here, what you should be doing, the best thing you can do is just make yourself write out the first few terms. Sometimes when you see the first few terms, it gives you, like, you kind of understand its behavior a little bit. So I could plug in 1 for n here. This would be 1. And the cosine of pi is what?
Negative 1.
Negative 1.
Okay. So when n is 1, we get negative 1. When n is 2, I would get a half times the cosine of 2 pi, which is,
Positive 1.
okay. So that is when n is 2. Could plug in n is 3. What's the cosine of 3 pi?
Negative.
-1, and then if n is 3, this would be -1/3. So notice, at first you might not think that's alternating, but because it's cosine and cosine oscillates, as you plug in 1 for n, you get a negative. As you plug in 2 for n, you get a positive. As you plug in 3 for n, you get a negative. So this actually isn't alternating. It's just kind of hard to see. It's hard to tell that up front. So the part that doesn't make it alternating is what we will call a sub n. Make sure the limit as n goes to infinity of a sub n is 0. It is. And then make sure that the second part, if you take a sub n plus 1 divided by a sub n, it is always less than or equal to 1. So I can see that. 1 over n is pretty easy for me to do in my head. So plug in 1, you get 1. Plug in 2, you get a half. Plug in 3, you get a third. Plug in 4, you get a fourth. It's getting closer and closer to 0. But on the questions that you struggle with that, you can find a sub n plus 1. That's where you plug in n plus 1 everywhere there's an n. You can divide it or multiply it by the reciprocal of a sub n. And if you picture this n basically canceling out this n, you're left with 1, which is less than or equal to 1. So the second thing is true too. And if both tests are true, it converges. Okay, the next one, or the last example here, is kind of trick question in a way. They're telling us this is not an alternating series, even though it looks like one. So I want you to think about, why do you think this is not alternating?
Two negatives. The negative one and the this one.
Okay, so when n is 1, this goes to, this would be a negative, right? And when n is 2, doesn't this become a positive? And when n is 3, doesn't it go back to being negative? So it sounds like it's alternating to me.
But
But the
your
cosine.
other one also alternates.
Yeah, but there's also a cosine here. So when n is 1, you get cosine of pi, which is -1. When n is 2, you get cosine of 2 pi, which is +1. Cosine of, or n is 3, cosine of 3 pi would be -1. So do you see how these would always be what? Right, they're always positive, which is why it is not considered an alternating series. Alternating series is where it alternates between being positive and negative. So sure, 95% of the time you see this -1 to the end, it means it's going to be an alternating series. But like we saw on the other page, with sine and cosines, sometimes that part can alternate as well. And if you have both of those, they could be canceling each other out and making it not be an alternating series. So of course, big picture, that would mean we'd have to do something else that's alternating to test. Limit as n approaches infinity of a sub n has to be 0. And a term divided by his previous term always has to be less than or equal to 1. If both those things are true, then the alternating series converges. Otherwise, it diverges. Okay, so the two things I'd like you to do today is I'd like you to, last class on your own piece of paper, 56, I had you write down the first 5 tests, the harmonic series, what's it look like, when's it converge, when does it diverge, what's it converge to, but also geometric series, piece series, integral test, and nth term test, the 5 tests we had done up until that point. So give me a few minutes here so I can check your homeworks and get those grades put in, and then I will give that back to you. And I'd like you to update your 56 with at least the 2 tests that we did last class, and I'll let you fill that in with however that makes the most sense to you. The last class we did the comparison test and the limit comparison test. So I'm going to ask you to add those to your blank piece of paper. Otherwise, the only thing you have to do is practice these 14 questions on alternating series. Okay, any questions before you get started? Okay. Again, I am starting to feel pretty sick, so if I was you, if you have questions, feel free to ask, but you may not want to bring up your paper to me. You might want to just ask me to look at it on the board with you. It's a little safer. 2, 3, 2, 3. Blake. Alyssa. Parent contact. And also, this is just about the halfway point for this last unit for you guys. Unit 10 has 15 sections to it, and 7 is almost halfway, so. You may notice, I think I verbalized this last class, but over here on upcoming assignments, I did change our next quiz from being 10-6 through 10-10 to 10-6 through 10-9. So, not that that means anything to you right now. It just was a little bit better of a break in the content. So assuming we stay on track here, that means I guess next Wednesday would be our next quiz. I know a bunch of you guys missed last week because you had school business for that quiz. Make sure you were signed up to come see me during advisory this week as soon as possible.
Just added 2 squared.
Oh, also before I forget, last week at some point I had posted about the upcoming ACTM contest. So if that is something you're interested in doing, you've probably done it in the past. There is a $5 fee to sign up. The competition is always on Saturdays, which is not the most convenient. But now that you guys know most of the BC content, you could do much better. Technically, you can participate as an AB student, but as an AB student, you don't know any of the BC stuff, and you're competing against BC students. So if you're interested in that, there will be a deadline here in about a week or so. So if you are interested, you need to make a note to get yourself the $5 and get it to me. I cannot sign you up until I have the money. That's not fair. The high school making money on you, that's the university's fee for paying the graders and stuff like that. And if you've never done it before, it's just a good opportunity to add one more thing to your scholarships or your college applications. I don't know, a couple years ago I encouraged some students to do that for pre-cal, I think, or no, calculus. They did calculus, and I don't know. There must have been 30 people take the test, but they did well enough to be in the top 25. So on their applications, they could say they scored in the top 25. They didn't have to say that there was only 29 people participating or whatever. So anyway, I'd love for you to do that, but again, I understand Saturdays are hard. Having to pay to do a math test is tough. But just so you know, there is a deadline that I can't budge on, so you need to be moving that way if you want it. And also, when I posted that on Google Classroom, I did link to my website that has a ton of old tests. That's the best way to practice and see what it's like and what to expect. So, anyway, that's all I've got for that. Let me put these homework grades in so I can get these back to you.
No. That'd be a year. Nice go. I don't know if I'll get the pockets. And they tell you, it's like the same thing. Well, some of yeah. But that'd be so sick. Wait, how many kids do you use?
Mr. Thompson. Yes, sir. For number 2 on like the II, would you add in a 2 squared there because of the end is being squared?
You didn't get it.
Didn't get it, yeah.
That's crazy.
And it's like going up by 2 every time.
Okay, you got to say that part again. I didn't follow.
So like for this one, since
Okay.
it's n squared plus 4,
Mhm.
and it's going up by like 2 every time, would
No,
you?
it only goes up by 1 every time.
Oh.
This is telling you
Oh,
what number
that's
it
right,
starts
that's
off.
right.
It starts off at 2, but then the next one
Okay.
would be 3.
So it'd just be plus 1.
Yes.
Okay. Fine.
I don't know if one of them got it, but I know one of them didn't get one. I think so. Oh, okay. So at least two, yeah.
Miss English said that, she prepares the students better, that's pretty normal. You get an interview, they're pretty like,
I'm nervous in the interview, I'm just gonna like crack out. Just say that's less than Dex, for sure. Dex, get in. So far, I think I have to. I don't know. There's nothing else. You got the best you can get. So thank you, Josh.
So you're at across the full plate.
If I get, if you get Chancellor's Pledge, that's from Eric, you get 12. That's my final. I don't have to get it. But I'm you gotta make money. The gamble scholarship money they gave me. Jake Hill. Did you get more, or did you lose it?
No. He said every week he did it, but he had a sports scholarship, he had the Chancellor scholarship, he had the fellowship, and the bachelor's, and then he combined all of them, he got like $160,000 to go to school. And he said on the weekends, he was just straight up going, gamble at the casino, and throw it away.
I'm back in all I saw the guy, but I just invested. That's crazy. That's what.
It's not even very expensive.
Okay, you do that during 5. I want you to do this. Finish this, then I don't care.
If it wasn't as good as last year with the military.
Thank you.
Okay, I passed back all the homeworks that I got. There was one with no name on it and an unfinished back page. If that sounds familiar to you, you need to come claim it because I didn't know who to give points to.
Yeah, this one's mine. Can you do the back page? Darn. Or
Yeah. zoom in like that. That's your face. Wait.
Finding and they didn't know what was gonna happen, so they both lost their jobs. FedEx and P&G, she couldn't nurse, so backpack in Europe for 7 months. And my mom returned us.
Oh, yeah.
Guys, are y'all making progress back there?
Just
Okay, well, I'm gonna have to split y'all up because y'all are not staying on task. There's plenty of empty seats in the front.
Yeah, so not even this, but it says explain why it does not apply to series, which I was thinking like. I guess so, yeah. Yeah, that makes sense. I was thinking what does apply to divergence, but that makes sense.
I'm just over here repracticing some of this, but I forgot that factorials come up in this, and I realize some of you may not have ever learned about factorials. So I feel like they probably should have put that in the start for the notes. But have you guys ever, I know some of you have seen it, but has anybody not seen a factorial, like what 3 factorial means? Okay, 3 factorial just means you start with the number 3, and then you multiply by the next number, multiply by the next number, all the way till you get down to 1. So 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1, whatever that is. Your calculator actually does have a factorial button, but even if you know where it is, as long as you understand what factorial means, I don't know. I can type this in my calculator as fast as I can find the factorial sign. They used to put that on the ACT a long time ago. I don't know that they still do. guess that they do because I don't hear any students ever really ask about it. But when you get to question 10, it just says n factorial, which n factorial would be n times n subtract 1 times n subtract 2 all the way down till you multiply by 1. So if you have more follow-up questions than that about it, then that's fine. But once you get to question 10, you can start using that. Yeah.
That's a gamma function.
What about it?
That's an extension of factorials, which is really cool. It's like it's based on intervals, and yeah, that's why we already covered like everything that you need to know.
For gamma functions?
It's the interval from 0 up to infinity of e to the negative t times e to the z minus 1.
E to the negative t what?
Times t to the z minus 1 dt.
Okay.
So if you do that, it allows you to compute the factorial of 1.
Okay, squeeze by.
And if you compute it out, like if you take the integral of each individual part, and you take the limit of that goes to infinity, it is just the factorial function.
Interesting. I don't think I've heard that before. Or if I did, I forgot about it.
Yeah, it's really cool. You use Riemann sums to prove that it is the factorial function.
Spaghetti becomes soup. Because soup is soup. How much sugar do you have to have for spaghetti to become soup? You can have like tomatoes and a lot of noodles and it's still technically soup. Unless you drink all that.
Will be now the cereal.
But even if you drink it, it's turned into the water, so it's raw.
Yeah, but so is spaghetti. You brought spaghetti into the hot water.